Hi again, I'm back with another video. This time it's not on the wildlife but on the astrophotography, which I'm heavily getting into at the moment. Big learning curve and quite expensive to build your gear up, so fairly basic at the moment. But I've had in mind for a good few months trying to get a photograph of the International Space Station transiting across the face of the moon, which doesn't happen a lot, so there's a lot of planning, a lot of luck with the weather, and obviously the luck with the gear being right. So I have managed to get out there, and I'm quite pleased with the image, which I've shared on social media and had some good feedback on it. So I thought I'd explain how I managed it. Now the video here initially will explain what apps I used from the phone to plan it, which are essential, and if you're into stargazing or you want to get into it, they're ideal for learning anyway, so hopefully you'll get something from that. I will then explain with various lenses how you capture the moon, the composition you get, how zoomed in you get on the moon. So I'll go from my wide-angled lens through to a telescopic lens through to the telescope that I got for Christmas, which is only a basic telescope, but it's doing a really good job. And then also with like a lens that magnifies it times 2 or 2.5. So I'll explain the moon transiting across those various compositions with those lenses. So hopefully you'll get something from it. I'll keep it as simple and concise as possible to make it at least interesting. So what I'll do, we'll start off with the applications I use. At the end of the video, I will just put a very little bit of detail on the software I use for post-processing to get the final image. But hopefully you'll enjoy it and you'll see the outcome at the end. Thanks for watching again. Now this is a great program called ISS Transit Finder, which is on the web. It's not an app on the phone. I'll put a link at the end with the website on. So when you pull that up, it will auto find your location, your longitude, latitude. It'll do elevation and start and end date. So there it's got latitude of 53.96 for York, and the dates there, you can change the dates, but it's doing it between the 27th of March and the 16th of April. You can change the dates there. So I've done a distance. You can change the distance that you would go to view it. I've just done 5k because I'm not going to be moving from home basically. Then what it does, it pulls up the next transit across the moon and the sun, and you can see it's found the 25th of March this year at 19:24 hours and 36.8 seconds. It's got the various celestial information there as well, but transit duration, it's only going to be 0.84 seconds, so I need to get those photographs in a very short amount of time. So that's a fantastic program that to get the location and transit of the ISS. Now this is a phone app I can't live without. It's Stellarium, which is a celestial program that shows you all the celestial targets you might want to look for, observe, plan to photograph. There you can see Saturn, Jupiter, Uranus, oh joke there, carry on going round, and there you've got the Milky Way. If you want to plan to do the Milky Way, Saturn, Jupiter, Mercury, they're all there. You can pinch the screen on your phone, zoom straight right in, and then you've got the moons around Saturn if you're interested in just learning the various celestial objects. So pinch back out there and you just rotate round to your northeast southwest. Then you can bring up the time and change the date and time. So the time we want for the transit is the 25th of March. And I think it was 19:24 and 34-ish seconds. So I'll take it up to 19:24, and then what Stellarium do, it's effectively showing you exactly what will be happening at the time and location that you set. So if we just rotate around to the moon, that's the position of the moon at that time, and there you've got the ISS approaching. So the Transit Finder software was bang on, which it would be because no doubt it's NASA based, and Stellarium links in very accurately. You will see probably the time is just maybe a second out because it's not the atomic time on this app. So you've got 1924-36, it's crossing over the moon. So stellarium is an essential for planning your photography and stargazing. Now, Clear Outside is a program really for checking the cloud. The worst enemy of any photography at night really is the cloud, because you can't see anything obviously. So here it's straightforward. You've got low cloud, medium and high cloud. I've just changed there to the current location of Dunnington, York. You've got low, medium, high and total cloud. So if you look at the top, you've got sort of red, amber and green colours. You're obviously looking for green stroke amber for the astrophotography, so it's pretty grim looking up all the way up till Monday, and Monday's looking quite promising. So if you look Monday from 1900 hours right through, we're going to have a clear sky. So there, I'm just changing location to Brimham Rocks. For instance, if we wanted to plan a photograph at Brimham Rocks and get some nice foreground image of the rocks and maybe a Milky Way, that's how you'd plan that. You do have to take account in the lunar phase, because the more full of the moon, the brighter it is, and it washes out the stars. So that's another issue that you need to plan the moon phase, being a newish moon really, but another great app. Now this is just a straightforward app for the moon phases. You can bring up the calendar if you want to plan getting a moon photography or to see how bright it is. As I said earlier, the brighter the moon will wash out the stars, so you need a more of a newer moon. So you've got your phases there, waxing gibbous on that last one. Then you've got a calendar, so you can see at a glance for the month what phase the moon is at. Again, it's ideal really for part of planning any nighttime photography. Fairly straightforward, and again another free app, so one I'd certainly recommend. And another simple app is the atomic clock, and this is the accurate clock really. All the watches and computers, phones are slightly out, so the ISS transit time is the accurate time. So ideally you have this clock. I mean, it doesn't matter too much because you can see the actual satellite approaching the moon, but at least you know you're accurate. Now the first option for photographing the moon would be with a wide angle lens. I've got my Lumix G9 and a 12 to 35mm wide angled lens. You'd use this maybe for getting more of a landscape with a composition of, I don't know, rocks for example, silhouetted trees. You could take them photographs and include the Milky Way, nebula and obviously the moon. So with a wide angled lens, when you're not zooming in, it appears less that the moon is moving, so capturing it is slightly easier. What I'll do now, if you just watch this video, you'll see that as I do a quick video of it, it won't look like the moon's moving, but in comparison, when you see the next videos with the bigger lenses, the moon will appear to move off your composition quicker and it gets more difficult. So just take a look at this video with the wide angled lens. So the second setup would be with my Lumix G9 camera and the 100 to 400mm lens. So what I'll do, I'll show you a video now of 100mm, and you'll see the moon transit across the composition. That's with the camera being static on a tripod, and then I'll do it at 100 and you'll see how much quicker the moon transits across that composition again. So take a look. Now the third option, which is what I used for taking the images of the ISS transit, that's the Skywatcher SkyMax 102 telescope I got. Still got my Lumix G9 attached, and I've just got an adapter there. That adapter attaches the camera to the telescope. So same principles with photography, just a bit more difficult, which I won't go into, to do with the focal length of this and letting light in for the image. But it clearly worked, and you'll see again, I'll just show you a video now with how the moon, how much quicker it appears that the moon is transiting across your composition, which again makes it more difficult if you're on a static tripod, because the moon is just phasing over your image and you've got to be quick to get it, or to get your full moon on your composition is more difficult. So take a look. Now a fourth setup is still got the telescope and the G9 camera, but now what I've got is a PowerMate times 2.5 lens, so that will magnify that focal length again, so we'll get even closer to the moon. But then again, as you'll see from the video, the closer you're getting, the quicker that transit's going. So again, on a static tripod, that moon's gone out of your composition very, very quickly. So it is even more difficult with that, although you can get closer into the moon. So take a look at this video so you can see what I mean by that transition to the moon. Now I've just mentioned with those other four options that the camera or telescope and or both are static on a tripod, which means it's completely still and the transit of the moon will go over your composition. Now what I've invested in, which I've been waiting for ages, which I'm going to use for things like the Orion Nebula, planetary and hopefully a bit of deep space once I can get my head around it, is this it's a tracker, a star tracker basically. It's an Ioptron Sky Guider Pro, and basically you set that up on your tripod, camera will be attached, and what it does, there's settings and one of them is for lunar. So once you line your composition up, so even if you zoom in right and you line it up, you have to polar align it. You've got to get it with the celestial polar, which I won't go into on here, but once it's set up and you get your composition zoomed in and you start it on the lunar, that tracker will basically follow the moon, so you can take photographs or video and the moon will stay in composition well, all the time, or for a long period anyway. So your standard of photographs are improved. You can take more photographs and stack them and improve the quality. So that is what's used for the main photograph that you'll see at the end of this project to get the ISS transiting across the moon. So I hope you enjoy the remainder of the video. First bit of software I use, which is free, is PIP, Planetary Imaging Preprocessor. So all the images I take, they're all images of the moon, I will put into this software, and it basically sort of lines them up and you can crop them so they're all roughly within the same position in the crop of the image. I then put all those images into Registacks, which again is free. Now this aligns the images, stacks them all together, and you have a lot more information in there which you can then just add to the sharpness and reduce some of the noise using the wavelets function on it. It is fairly straightforward to use. Then that image I put into Photoshop, where I set up some layers and I changed things like the curves, the highlights, the tones, just to make that image more pleasing to the eye and as maybe you'd imagine to see it. Then when I've completed what I'm doing in Photoshop, I export that to Lightroom, where I do some very final fine tuning, such as exposure, contrast, highlights, shadows, a bit on the sharpness and clarity, and reduce a bit of the noise again. Right, I'm here to try and get a photograph of the International Space Station transiting across the sky and going over the moon and getting photographs. I'm proper giddy because I've been planning it for about 2 months, and it all banks on whether there's cloud, and it's looking quite clear. Just to explain the gear, I've got my telescope, which is a SkyMax 102 telescope. I've got my Lumix G9 attached here for taking photographs, and I've got my Ioptron Skyguarder Pro, which is probably essential really to get this timed right. There's a lunar setting, so once I align that with the celestial pole, which I won't go into on here, skew that across to the moon, and then press start, it will hopefully track the moon. If it doesn't, I'm going to bin it all, but hopefully we'll be alright. I've then got an intervalometer, which means as that ISS approaches, I've got an atomic clock app with the exact time, so hopefully I won't miss it. I'll press continuous shoot on that just as it approaches the moon and get a series of photographs. So that's my plan. If the cloud come, I'm going to go absolutely mad, but hopefully we'll get the shot of the ISS transiting the moon. Let's do it. Right, we're here folks. It's night time. ISS is coming, it's on its way. I can actually just about see it. Unfortunately, I've only got the one camera. If I had two, I'd photograph or film that as well, but I can't. I've got my atomic clock on here. We're looking at 20 seconds left, 20 seconds left. I've got my intervalometer here for taking photographs. It's on its way, it's on its way. What you've got to understand is there's 6 people on there, and it's travelling at 5 miles per second, and it's going over my house now. It's bright as anything. It's going towards that moon. There was a cloud earlier, but it's gone. It's on its way. It's getting there. Right, we're nearly there. Let's do it. Give it some. And that's it. It's gone across. It's gone across. It's not looking bad. I think I've got it. Don't know how clear it'll be, but I've got it. I've done it, planned it, and I've managed it. So I'll upload it all soon, and hopefully we'll get a photograph. Thanks for watching.
Ground control to Major Tom. Take your protein pills and put your helmet on. 10. Ground control to Major Tom. 8, 7, 6. Commencing countdown, engines on. 3, 2. Check ignition and may God's love be with you. This is ground control to Major Tom. You've really made the grade, and the papers want to know whose shirt you wear. Now it's time to leave the capsule if you dare. This is Major Tom to ground control. I'm stepping through the door, and I'm floating in a most peculiar stars look very different today.